Hello, so this is our assignment 2. It's on trees. One thing to note is I had to put in my full path. It's just a bit easier. Some people, the relative path is enough if you configure everything correctly. But this is basically the overview of our system. So we can start with our data. So if we go in here, we see that we have title, artist, danceability, and a few other attributes together that can be used for the purposes of music recommendation. We have Javadoc. We'll have a link to this in our PDF, but for example, if I go here, I can open it up and you can go in and kind of see every method, etc., etc. And yeah, so we get to our source directory. We've created a binary search tree to help with the song recommendation. When we go to main and we run this, so we have two implementations here. First of all, we have our tree, which happens to be a bit faster than directly pulling from a CSV. So this gets songs which are similar to each other in terms of tempo, and it recommends them. It runs in 8 seconds. This can also be done directly from having a big long CSV file, just getting a column, sorting it, or somehow just, going through them linearly and figuring out which songs are a best match. So I was thinking initially that, well, if we just had one column, so if we look at danceability, if we just sort this, now we could use some sort of binary search and get something that matches pretty fast. Well, the reason this solution wouldn't be that ideal is that if you sort by one column, the rest of the columns aren't sorted. So on a grand scale, this wouldn't be a good recommender because it only takes one attribute into account. The reason we only use one attribute at the moment is just because it's just a minimal viable product, just to demonstrate that this can work. But on a grander scale, it would be an amalgamation of all of these different attributes, and that would give you the best pairing for a given song, and kind of develop a music preference or music taste per user. And then future works, so something that can be worked on in the future to kind of have that amalgamation. It would be a bit of a grander scale tree. So this is a kind of a library, a Weka library, uses machine learning to kind of give you a full scale music recommender. Yeah, well, I haven't set it up for relative path to work, so I need to add the full path. So here it's just telling me I have M1 and that it doesn't support it, so it's just a warning that can be ignored. But we get a J48 prune tree, and what it's telling me is that given playlist blue, it would recommend me playlist green. So what that's basically saying is that these are the different songs of a given playlist, and if I was someone who happened to be listening to playlist blue, it would recommend me this green playlist, and that goes down the board for each of those playlists as well. This was just a small scale test, but it kind of ties back in with this. So if you had a playlist and let's say the average danceability of that playlist is this, and then the average energy is that, and the average loudness is that, etc., what would you recommend in the future to a person who wanted to listen? So that's why, getting it directly from Excel wouldn't be that fast or efficient of a solution, and it's much better to have a kind of a binary search tree to make that decision for you, or a decision tree to kind of recommend you the best music. We have made some JUnit tests, just to test, coverage of kind of the methods that we created for the tree. So, you have insert, search, delete, all of those. We created a seeder just to keep things isolated, but also reduce the amount of initialization work required. And also for this like future works part using Weka, machine learning. Weka uses machine learning, but it's quite a complex tree. Also some tests made for that just to see that you can load the data properly. So, in the future, if someone did want to build a full scale classifier or load different types of data that might not be ARFF, they might want to use CSV and such as the likes. This is a full scale Spotify playlist data set. It's very large at the moment. I think it was something like 100 megabytes. Might delete it because it is eating up all of my GitLab long file memory. So yeah, also Weka requires external downloading, so that's done using Maven, which is a good package manager. Keeps everything in shape for you, so you don't actually have to install any jar files. But everyone already knows about that. And yeah, we had a breakdown of work to make sure that everyone did their part equally. The plant UML diagrams and Javadoc will be uploaded soon. I guess they're already mostly there, but still a bit to add. I just had to make this video a bit earlier. And so right now, this does run a tiny bit faster than direct from CSV, but if we added more attributes, the difference in performance would be even greater. So our tree would run many times more efficiency-wise than pulling directly. And, well, you might say that, well, maybe the tree costs more memory to create than just a CSV. But the number of users who are requesting a song recommendation is far greater than the number of songs being added to a collection or, the database. So what we were focusing on here is user song recommendation. So it's really focused on the user side of thing. So given that the tree is already created and given that the Excel spreadsheet or whatever kind of data file is already created as well. Yeah, so that's it.